The next activity is about the distance sensor named HC-SR04. The ultrasonic wave is transmitted from the sensor head and the reflected wave is then received. The time spent between the emission and the reception will be used to compute the distance between the sensor and the target. HC-SR04 can detect a distance up to 400 cm. There are 4 pins as shown in the figure below. The first pin, VCC. The sensor requires 5 DC volt, so you may connect this pin to the Raspberry Pi, pin number 2. The second one, trigger. The sensor will be activated by connecting this pin to GPIO 18. The next one is an echo. The sensor will receive the reflected wave from the target and will deliver this signal to GPIO 24. The last pin, ground. The common ground of the system must be connected to this pin. There is one tiny problem when HC-SR04 is connected to Raspberry Pi. The echo pin will transmit around 4.5 volt to the Raspberry Pi, but the input signal to GPIO-N cannot exceed 3.3 volt, or else the Raspberry Pi cannot be operated properly. So 2 series resistors are then connected to resolve this problem. The connection between Raspberry Pi and the circuit is shown. Make sure that the correct pins are being connected. VCC pin is connected to pin number 2 so that 5 volt is supplied to the sensor. The trigger is connected to GPIO 18 so that Raspberry Pi can send a command to activate the sensor. The echo pin is connected to GPIO 24, but because of that high voltage received from the sensor, so 330 ohm and 470 ohm are connected between these 2 pins, and the voltage drop across 470 ohm will be used as the input to the Raspberry Pi. The last one, the ground, is simply connected to the ground of the Raspberry Pi. Let's explore the Python code. Begin with import 2 libraries, rpi.gpio and the time. The next, the mode of GPIO must be set up. There are 2 possible modes, BCM and the board. You can find more details about the way we set up the mode at the appendix of the workshop. And then set up GPIO number 18 and number 24 to be the input and the output of the system. Once the wave is transmitted, the echo is 0 and the start time is measured. Once the wave is reflected, the echo turns out to be 1 and the stop time is measured. And the time we spent between stop time and start time will be used to compute the distance by a basic formula. The distance is the time we spent multiply the velocity of sound wave in the air and divide by 2 because we want to get only one way distance. Right now, the speed is set up to be 349 meters per second. But if the temperature of your surrounding is not 30 degrees Celsius, you may need to adjust this value by using the formula provided in the appendix. The result that we expect is the distance, so you need to keep computing the distance as a loop. We recommend you to try to use the command try. As long as it's true, the distance is computed and print out to show the user as measure the distance to be something centimeter and sleep for 1 second before the next computation. And the system will be reset if the user places Ctrl+C. The message measurement stop by user is printed out and the GPIO will be cleaned up. We recommend to try this loop so that you don't have a problem with communication port.